So yeah, that's me. That's the cake. It's usually not orange, but don't worry about it. It works most of the time, like this. So yeah, I will talk about the Lotus-Miner or the Lotus storage provider software stack or whatever you want to call it. It's hard to tell what it is. It's a lot of things. Okay, so yeah, it's a lot of things. I will talk about what it means to be an SP, how you become one, what power, is, how to maintain power, how to get power, how to run at scale, and then I will have a brief Q&A, and after that I will talk about the future plans. Maybe we'll probably have some time. There'll be that small Q&A in the middle for 2 or 3 questions, and then hopefully have time for more Q&A after the future plans. It may be dense, so bear with me. Okay, so what does it mean to be a storage provider? It generally means that you want to provide storage to Filecoin. It's what it says on the box. But in more practical terms, it means that you get data and you store it. And the reason you do that is you want to earn Filecoin. What? Okay, it's fine. You want to earn Filecoin. You spend a lot of time in spreadsheets. Maybe you have a horrible data hoarding problem, or all of the above. Why? How do you, earn Filecoin? You win blocks. How do you win blocks? You participate in this lottery that happens every 30 seconds. And the lottery works by just drawing a random number and multiplying the total power by it, and then getting another random number derived from the first number and multiplying it by your power, and then doing some more math, and you either get a true or false. If you get a true, you won, and you can mine a block. You can attempt to mine a block. So you are then challenged by the network to also prove that you are storing one random bit of your storage. It basically checks that the amount of power you have is actually real and you cannot fake it. But yeah, let's say you've proven to the network that you want a block and you create a block. Now you have to send it to the network. So you do that. The network may or may not accept your block. It probably will if you have fast enough internet and if you've proven the thing on time. So great. You send the block. The network accepted it. Now you get a reward. So you have fill. Great. That's what you do as an SP. So yeah, mining is great. It's very simple, but it depends on this power thing. So what is power? Filecoin is a storage network. So it's kind of logical that the power is based on how much you store. And so we've chosen 1 byte as a unit of storage. So if you store 1 byte, you have 1 power. But Filecoin is a network for real data. And so we then decided that, well, if you store something that's considered real data, you get more power. And we also decided that, okay, if the data is real, we get 10 times more power. So we have a very good incentive to store real data. You've, know what power is. Power comes from proving storage to the network. And the way you prove storage to the network is by sealing and more precisely by seeing sectors. And what are sectors and why do we need them? Yeah, sector is just the minimum. It's the smallest amount of storage we can prove at a time. It could be larger, but we cannot really make it much smaller. It makes some assumptions very complicated. So actually having sectors be 32 gigs or 64 gigs, just the right balance between how much memory you need to seal stuff and how much it costs to seal stuff. It comes from how the SDR-based PowerApp works. There are maybe other mechanisms, but so far we think this one is the cheapest, I believe. I think. And this one is also the one that we know that is secure. We know of cheaper constructions that are broken. We actually know of many. And so, yeah, we have this one for now. Maybe there will come a better PowerApp. Maybe, hopefully, we'll see. So, yeah, getting power from seeing sector is great, but getting power from seeing sectors with real data is better. So how do you get fill plus data? You go to the other room, they know better. But the simple ways for especially the smaller, medium storage providers is to go to onboarding platforms and other clients like Estuary, Web3 Storage, Evergreen. The large data set working group stuff also probably can help you a lot. They have infinite data. And so, yeah, you basically go to clients and go get data. Simple in theory. And so, yeah, you've got data, and now you need to seal it. How do you do that? So the first thing you do is you need to create a sector. And to get a sector, you just need to find either 32 or 64 gigs of data. I will use 32 gigabytes for in place of sector size, but it's one of those you can choose. But yeah, you get 32 gigabytes of data. You put this into one block of bytes, and deals come with pieces of data attached to them. So each deal refers to a piece of data. You get a bunch of pieces. You get a sector. Then you do the first step of the seeing process. That's pre-commit 1. At least that's what we call it. And really what you do in pre-commit 1 is first you compute some Merkle tree hash of your unsealed data. And then in the second step, you perform this very weird sequential process where you build 11 layers of some very specific Merkle tree that you can only do sequentially, and it's called SDR, which stands for stacked DRG, which DRG stands for depth robust graph. And it's basically a type of graph where you need to store some amount of parent nodes to create the later nodes. Otherwise, it's very, very, very expensive to compute. And we create 11 layers of this graph. It still doesn't encode your data. It's just like an encryption key. And then in the next step, that's commit 2, we go and encode your unsealed data into the, prepared encryption key that we created in pre-commit 1. And we built some Merkle trees on top of that. That's highly parallel, so it can happen on GPUs. So you definitely want the GPU for pre-commit 2. And for pre-commit 1, you only really need a whole bunch of memory. Then you send a message to the chain, and you wait. The message you send contains the sealed CID and the unsealed CID, or comd and comr, or commitment to the data and commitment to the replica. There's probably 5 different names for that same exact thing. But yeah, so we send the message. The message is the pre-commit message. And this message tells the network that, hey, I claim that I will be able to prove that I am storing this, that I've created this replica for this data in this amount of time. And the reason for having the pre-commit message is kind of technical. And in theory, we could just have a one single commit step. But if we do this in this 2-step process with waiting, this gives us some better security, and it makes the proving process, so it makes the commit snark much lighter and much cheaper to compute. And at the time we were developing Falcon, that also meant it makes it physically possible. So yeah, we do this 2-step process. We send a pre-commit. Then after some time passes, and we finally have arrive at the epoch at which the network gives us a random challenge which decides which parts of that sealed data we have to prove to the network. So we get the randomness from drand. It's just the unbiasable random beacon Falcon uses. And then we feed it into the step that's called commit1. That step just reads a bunch of sealed data and all the associated Merkle proofs. In total, it's give or take 8 megabytes of proofs. And yeah, so we got 8 megabytes of proofs. We need to send them to the blockchain. That's not good. It's a lot of data. So we compute a snark. And through this, snarks just let us prove some claims are true. And in this case, our claim is that we can prove that we have created a copy of data that's unique. And this is the same thing that 8 megabytes of Merkle proofs prove. But the thing that comes out of a snark is 2 kilobytes. So it is literally 4,000 times less data for proving the same exact thing. And yeah, then we send that proof to the chain, and the chain believes us if the snark verifies. So great. We have proven that we have created a new copy of data to a blockchain network. And so, yeah, that's great. There is another way to get power, and that is SnapDeals. So through seeding sectors, we can either create empty sectors or sectors with deals. If we create sectors with deals, they can contain fill plus data that gives us the 10x power for that data. But we have this other thing called SnapDeals, which lets us do a similar thing, but it's mostly for just upgrading, like putting new data into existing, for now, empty sectors. And this is very cool for many reasons, mostly because it's fast. But if we sealed some C sectors way before, we may want to reuse this storage to gain more power. And if we get some fill plus deals, we can put them into our existing sectors, get more power. And we can also just use it to onboard data faster, or to smooth our work, to smooth our workload on the sealing hardware. So we can just seal at some constant rate, just create C sectors. But then if we get bursty client demand, we can use SnapDeals to have more onboarding bandwidth. And yeah, there are like many other valid reasons to use SnapDeals. Some clients care about latency. That really, really helps because the SnapDeals process more or less 20 minutes. So yeah, how does it work? You get data, you get an existing CC sector. You do a replica update, which is basically what we do in pre-commit to. And you basically, you encode the unsealed data into an existing sealed sector, just in a slightly smarter way, which makes it impossible to know what bytes are going to come out in the sealed sector. It's a very tricky, very fun math. Then we do a similar thing that we do in commit 1, just with slightly lighter proofs, because we don't need to prove that we have sealed, that we've created a copy of data. Like we already have a copy of data, we just encoded real data into the existing copy, so this is much lighter. But we still snark the result. It's a fairly light snark. It's not that light. It's comparable to the PowerUp snark. Really, most of the weight of the PowerUp snark and the SnapDeals snark lies in having to prove many SHA-256 like trees, and those are very, very not friendly to snarks. But yeah, we've done that, and that's how SnapDeals works. Next, so yeah, we have some power. We have to also maintain it. And the way you maintain power is you just answer to network challenges. And those come in through WindowPoSt. And WindowPoSt is fun and also annoying. Yeah, we had many other ideas throughout the development process of Filecoin how to prove storage. WindowPoSt seemed to be good, and it is still very, very good. It's way better than any other solution. So to give you some idea, one way that Filecoin used to work in pre-testnet days is that on every single epoch, you had to run the same computation as for winning post on a bunch of random sectors. That was called election post. And like to have any chance of winning blocks, you have to run post on every single epoch, even if you didn't win, because that's how you check that you won. And so yeah, that wasn't so good. So now we have something better. We have two posts. One of them is WindowPoSt. Essentially, every sector that's onboarded on the network gets checked daily. And the checks happen in so-called deadlines. So when you create your miner actor, you get assigned a random time of day at which your first deadline starts. And then you get 48 deadlines. So in a day. It's like just windows in which sectors are grouped to be proven every day. And yeah, so when time comes for a deadline with some sectors, you have to go read some random number that's generated by the network. I think it comes from DRAND. Then use that random number to generate some challenges for what data you need to prove. You read that data, you snark the data, and you join a WindowPoSt, and you send it to the network. There is many things that can fail in this process. So yeah, the Lotus-Miner takes care of most of those things. But yeah, like things that can fail is, your chain may be out of sync, your connection to the daemon may be dead, your storage may be dead or slow, or both. And yeah, then you may be out of funds to send your post, or your post may fail randomly because gas numbers changed, or your message may be slow to get on chain, like so and so on. It's surprisingly hard, and there are so many ways this can break. But yeah, that's WindowPoSt. Let's say you manage to send it every day. And so yeah, that's basically the part where, it's like how and what you do as an SP. It's just like onboard storage and prove it and mine blocks. Very simple. There's nothing more to it really, technically. So yeah, how do you run Lotus? If you are a developer, you buy a very beefy computer, or a medium beefy computer, and you just start a Lotus daemon, start a Lotus-Miner. If you run it for a longer time, you probably also start a Lotus worker. You may or may not start another process for the market, like a boost node. But yeah, like overall, it's a really, really simple setup. It's just one computer. Probably run it in like Tmax. But yeah, like it's just like the tiniest setup we support today. Not really interesting to most SPs because you can't possibly mine on this today. So a more realistic setup, you start getting a pile of computers. And yeah, you run a Lotus daemon, a Lotus-Miner, and boost. Those processes may be on different computers. They may be on one computer initially. For reasonably small scales, can probably get away with just a single computer for all the light processes. And then you get a bunch of workers. You get workers like for pre-commit 1 and 2. Those can be on different machines. Those can be a single machine. You get another set of workers for commit 2. You can execute them on the same machines if you have GPUs balanced out. It's a very fun game to play in Excel in spreadsheets. Yeah, there's quite a lot to it, like balancing and having efficient hardware setups. Like the thing that's on the slide is horribly inoptimal. You do not want to run this setup. Yeah, and then the other part is you need some storage. If you're a small SP, you can probably get away with putting hard drives into the same servers that seal your storage initially, but you will very quickly find out that you need more drive base. So you'll start, getting real storage servers, and you'll need to configure some real scalable storage. Many people get away with just, initializing a giant RAID and using any file system that works per server and using NFS to connect to Lotus. And it kind of works quite a long time, actually surprisingly long time. But at some point you will notice that NFS is a horrible solution. And there are far better network file systems. You will probably want to use something like Gluster or something like Ceph or something custom. Or you can also just have still independent servers but run storage workers on them. And storage workers are just sealing workers which are not doing any sealing work. They just accept sectors and respond to changes. So yeah, it works quite a long time. You can scale a decent amount. So how is a small SP different from a big SP? You have more computers, way more computers. You have rows of computers. And yeah, the first thing you do as a medium-large SP is you want to make post work all of the time instead of most of the time. So you get post workers. Post workers are just dedicated processes with their own GPUs. So the GPUs are always available. And yeah, the second thing you do is get more storage, more serious storage. And yeah, it's just more computers. And yeah, to be fair, Lotus wasn't designed to be super large scale. You might have noticed that in Y's talk, we were mostly about going fast and doing simple things. And it kind of shows. So in the second part, I will go more into how we want to address things. But yeah, like this is probably the most complex setup that Lotus supports today. Today, if you connect more than, 100, 200 computers to a single Lotus node, it will be very unhappy. But yeah, that's the plans for the future. Any questions so far?
So just to be clear on the WindowPoSt requirements, is it possible that a large storage provider is doing WindowPoSt every window of the day? Or is it per? Okay.
Yeah, so I believe that you can fit something like 72 terabytes worth of sectors if you're on 32 gig sectors. You put 32 gigabytes of sectors in a single partition, which then if you have more than one partition, you go to the next deadline, next deadline, next deadline. And this is something like 2.5 petabytes to have all deadlines full of at least a single partition. And what happens if you cross that, you just like add more partitions to deadlines. So you have to compute multiple WindowPosts per partition. And this is where you actually, when you need post workers, because you need to compute multiple WindowPosts in parallel, and I realized that Lotus doesn't do that today, I think, but it is something that we need to fix, and it's not hard. If you are a really big storage provider, you just compute multiple WindowPosts.
Thanks.
Okay, well, if there are no other questions. Plans for the future. This is very simple, I promise. We know that there are many limitations, and they are actually not caused by all that many reasons. It's actually a few very simple limitations for making Lotus scale really big. At least we think so. If you think we are wrong, please tell us before we do this work. The first problem is that Lotus daemon isn't perfectly reliable. And usually, often what happens is your chain node that your Lotus-Miner is connected to will die, or you need to take it offline for maintenance. It can happen that there's a network upgrade and you need to take your Lotus node offline, and then you may miss winning blocks, you may miss your WindowPoSt, it can mess with your seeding pipeline and so on. So the first thing we want to do is to basically just add a way to connect your Lotus node, your Boost node, all the nodes that we need to talk to a chain node, to just connect it to multiple chain nodes. And this sounds simple in principle, but there are some problems. So we sign messages on chain nodes, so you need to coordinate nonces. You want to be really, really careful with mining blocks to not get slashed if you mine blocks with two different block mining processes and send them to the network. And also, if one node gets out of sync, you probably don't want to use it. You want to use different nodes in the cluster. So it's, on paper, very simple. Just connect to a bunch of nodes, but you actually need to coordinate them a little. And yeah, this work is actually happening. It's in a PR by Shrenach. And it's probably weeks away from landing. We keep discovering new and new reasons why it's more complex than we thought. But yeah, overall, this is probably a problem that will be solved in this year, hopefully. It'll be really annoying if it is a thing for longer. So yeah, we want this. That will be so nice. Yeah, next. Boost scalability. That is something that the Boost team is very more qualified to talk about, but essentially we want more boosts. More boosts better. We want to be able to connect multiple Boost nodes to a single Lotus-Miner node, and we probably also want like any Boost process to be able to talk to multiple Lotus-Miner nodes. So it's like this many-to-many thing going on there. And it really just allows, the Boost process to not be bottlenecked by any single computer not being able to push bytes fast enough. So yeah, that is easy. So when we built Lotus-Miner, we decided that we want to keep sectors in storage paths, and we'll just index them in the central process in some in-memory maps. It's fine. It's not fine anymore. So since then, things happened. So there are SnapDeals. SnapDeals break a lot of assumptions if you just assume that your sector data never changes. And then you implement changing data in sectors, things will break. That is one of the major causes with the issues with SnapDeals. Another limitation this introduces is you cannot use the same Lotus storage paths for sectors of different miners. And this is a very annoying limitation. It's less annoying if you use enterprise file system like Gluster or something that just create a pool per miner. It's slightly better, but still, we would like to not have this limitation, and we'd like to be able to just connect use the same storage for different on-chain actors. Maybe not even actors that we own, that I will go into later. So yeah, we want to pull the storage index out of the Lotus-Miner process, and we'll probably use some established database that is that everyone knows how to run reliably. We don't want to reinvent the wheel. We did a lot of that, and maybe we can do something simpler. So yeah, we'll probably use something like Redis, TBD, some database to store metadata about where sectors live and this kind of thing. So yeah, that is part one of how to make Lotus scale. The real big problem that exists today is how tasks, the seeding tasks, are scheduled. It's not good. So in the initial early days, we needed to move fast. So we just wrote a scheduler, and then we make it less bad progressively over months and years. So now we have a scheduler that's mostly not bad, and it's still not good. And there are many ways to make it better. And the best way is probably to get rid of it and just replace it with something sane and simple. So we probably want to move to a simpler model where really the scheduling decisions are made on workers. And the Lotus-Miner process really just sends messages to the pool of workers that is hey, I want to seal this sector with this data. Or I want to do pre-commit 1 or pre-commit 2 on this data. It's just much simpler. This also allows you to put Boost processes and talk directly to workers to do the remote compete, Or even better, it lets you participate in sync marketplaces where you kind of have a sync marketplace plug in directly to this like centralized message like queue that goes to workers and be like, hey, if you have time, also seal this sector. And yeah, like it seems like a much simpler architecture. It seems like workers can do much better job of deciding if they are ready to take more work than the centralized scheduler, which is some wild model of the worker resources. This is very TBD. I don't know if we go this way or a different way. Definitely talk to us if you have different ideas, or if you agree that it's good. Pray also try to tell us. Yeah, this is we're trying to figure out how to make Lotus a lot better. We don't know when this will be happening, but yeah. Sure. Yeah, we can talk about it. Yeah, other interesting things that are going on in the ecosystem is Sync as a service is a cool idea. You can just pay someone to seal stuff for you. And we spent a bunch of time this year, a few months ago, with some people who are very interested in building this stuff. And we've actually shipped a set of new APIs in Lotus that already make it possible to import sealed sectors, or even partially sealed sectors. And Lotus will continue the sealing pipeline from there. It can also call back to the sealing service for doing some other work, like reading commit 1 challenges, or reading, or like doing commit 2 for them if like that's full sealing service. It's possible to pay someone to seal sectors for you without giving them your keys, which is very convenient because they cannot steal your money. And yeah, so that's happening. It's probably a bigger deal than it seems initially because it makes it possible to become an SP without investing into sealing hardware at all. It's very, very cool. And another, like the next logical step from that is full sealing marketplaces. You can trade your like spare compute. If you have a lot of storage, you can like buy compute from some other SP, and like vice versa. If you have, a lot of compute but not all that much storage, you can pay someone to compute stuff for you. We'll see when that happens. It's happening. We'll probably see first seeing services in weeks. Yeah, probably talk to Daniel if you want to hear more. Seeing marketplaces, I'm not exactly up to date on, but yeah, this is the stuff that's happening. Wow, that was quick. I want to hear questions.
If you could have done one thing differently before launch, what would it have been?
I would like to know that the scheduler would be such a pain.
Right, so I think that we have had some talks going forth and back on how much needs to be inside Lotus. So this is more like a comment and probably also something for you to respond on, but I heard earlier on that Stefan was also talking about having other storage backends. And I just wanted to know what is the kind of the Lotus dev angle on this, because obviously we don't want everything going into Lotus, but then on the other side, we are competing with cloud providers that has these kind of benefits. And I do see it like Lotus is basically the one that is that wants to audit the data because of the Filecoin spec. Yeah. But we need to audit data, and that is not a usual case. So So are we looking to actually integrating better support for that in Lotus? Or is it still like that is the SP's own problem, how to create storage that works with that?
Yeah, so we want to stay flexible. You might have noticed that like the simple dev setup is one computer with barely any storage, and we need that to still work. So there is a very large degree of flexibility that we need. But what you're saying is very valid. So we will maybe look into this. We probably want to rewrite a lot of the worker, like the current worker code. It may be in Rust to just have way better access to the proving APIs. And if we do that, then it's very, very easy to abstract the storage layer and make it possible for SPs to use literally whatever they want. Like, it would be very nice to have direct object storage access, like from the workers. And if that's the case, then you can do whatever you want as an SP without having to go through the pain of storage paths, mounts, things. That is something that's on the table.
Yeah, I just want to add on to that. It's like as we are thinking about next steps for Lotus-Miner or Field-Miner for support large scale enterprise storage provider. If you're a client solution provider that have storage expertise and knows how to help us to make things better for our storage provider community, I'm looking for help. Our team is looking for help. So if you have ideas, reach out to me. Again, Jenny, Juju, or Falcon in Slack. You can find all of us in the Field Lotus Dev chat. We're looking forward to collaborate with different solution providers in the ecosystem to make the next generation of Lotus-Miner. We cannot just do it all by ourselves, so.
Maybe more of an observation, but also a question. It looks like we're moving towards a more microservice type architecture where there could be specialization for sealing, for example. Is there an explicit, and I think Ayush kind of alluded to hey, we want Boost to do storage or other people to make better implementations. Is there a path where we see specific areas we want to create those APIs to make it easy to specialize for these services? Or is it more as we see these problems, we'll break it up at that point?
Yeah, I think what is likely to happen, is the services that are heavy, that are kind of logical to scale, will be broken into their own processes. So, workers for the sealing part are a very obvious box to make scalable. Another thing that's logical to make scalable is post workers or the chain nodes. You don't really care all that much about scaling. Maybe if you are some data platform. But chain nodes are kind of an easier case, but you can also scale them if you really want to, and you mostly do that for redundancy. Other things, the sector metadata process, that you can run reliably, even if it's not redundant. You can also shard it fairly easily on sector numbers, but it doesn't really make all that much sense to scale. And then you have the market sides of Boost. Boost makes a ton of sense to scale, and in two different ways, as was mentioned. It's you can scale for retrieval and you can scale for storage. And those processes talk directly to the workers. At least they send data directly to the workers. So there's not much else to scale in there. I hope that we capture all of the bits that need scaling. There are always new surprises. If you design for some scale and then someone makes use of your software at 100 times the scale, you'll be surprised at what things can break.